Hi, everyone. This is Hina Juneja from the Tech Vision team of Frost & Sullivan. I have an over decade of experience in the ICT domain, and at Tech Vision, we closely watch the emerging technologies on both hardware and software, such as AI, AR, VR, embedded systems, edge computing, cybersecurity, and even technologies related to telecom. Since we all know that technology today sits horizontally over all industries and functions, and that is exactly what Tech Vision job is, to provide technology-focused insights covering all domains. At Tech Vision, we track innovations, technology trends, draw insights on focus topics. The best part of the year is when the entire team sits down to brainstorm through a long list of technologies to find the top 50 picks of the year, which happens at the start of every year. So yes, we do provide a bag full of insights. Today, we are going to talk about growth opportunities lying at the intersection of cognitive digital twins and spatial computing. These two technologies operate separately, but together can provide a dynamic virtual model that represents real-life spaces or scenarios. This can help test the functioning, make changes, and analyze efficiency much before actually creating and investing in the live space or a scenario. So yes, you can save on your capex. I would like to first introduce our guest speaker for the day, Daivat, who is the Chief Business Officer at Cloudworks. Daivat, can you please provide a brief introduction about yourself?
Thank you, Hina. Hi, everyone. My name is Daivat Pujara. I work at Cloudworks as a Chief Business Officer. I come from a background of engineering and MBA, and I have around 7.5 years of experience, and very excited to interact with you all and talk on digital twins and its scope in the global level.
Thank you, Daivat. Also joining this conversation is Soumyadi. We call him Sam, who's from the ICT cluster, and Jason, who is an expert in semiconductors. Sam, can you start with your introduction?
Sure. Hi, hello everyone. I'm Shomadip and also known as Sam. I am working with Frost for the past 3 years now, and I've been in the industry for almost 13 years. I predominantly work on ICT topics, uh, mostly emerging IT topics, and look forward to our session today. Over to you.
Thanks,
Jason.
Sam. Hi, guys. I'm Jason Matthew, and I'm a senior research analyst with the Tech Vision cluster of Frost & Sullivan. So basically, I focus on the microelectronics and sensors clusters. So basically, within the electronic sector, semiconductors, and also a little bit on AMA, advanced manufacturing technologies. So I'm with Frost & Sullivan for the past 2.5 years now, and I'm excited to join this session.
Thank you, everyone, for joining this session, and special thanks to our panel. So let's get our session started and understand the fundamentals of these two technologies. So Sam, could you tell us what are these two technologies, cognitive digital twins and spatial computing, are all about?
So cognitive digital twin and spatial computing, I will briefly talk about it before we get into understanding how they are combined force that we can look into as a big opportunity in the coming days. So digital twin is basically a digital replica of a real infrastructure or a building. It could be machinery, ecosystem which has been around for quite some time now. But if we look at how they have evolved, they're quite different now as compared to earlier. Similarly, spatial computing is something that we have also known as AR, VR, but AR, VR are only component of spatial computing. So before getting into the amalgamation, I would like to talk about how cognitive digital twin has evolved over the years. To give you a brief idea, obviously, digital twin has been around for a decade, over a decade now. But if we go back into the time and look at how it was being used initially, it was very static, more like I would say, 3D models of buildings or infrastructures, more CAD-based design that were available to companies and individuals who were working in those companies. And they were mostly used primarily for visualization. But those visualization were dated, mostly historical or very static, which has been around for quite many years. So any recent changes would not show up in those designs. Over the years, the focus has been on real-time representation of the same, like in digital twin. And as we see now, cognitive digital twin is making use of AI, machine learning, and trying to show the real-time data-driven designs which are available to users, and they can get a real-time view of that particular infrastructure or ecosystem to have a better idea, not just something historical, right, which has been around for years. Now, how are they different? I would say one of the biggest change is the cognitive and the predictive part, right? In the earlier iteration of digital twin, it was mostly focused on how you know digital representation can be done in a uh, I would say high quality representation or some sort of controls. But more and more with AI, we are seeing those controls to be spreading and connecting with each other. It's not just asset level. And when I say asset level, I mean it's not limited to a particular part of the building or particular machinery. It is now a system wide visualization of things. It could be a smart factory, it could be a smart building, it even can be a smart city where you can have a system wide view of the entire asset or ecosystem in a digital form. Now, spatial computing obviously has been mostly known for VR, augmented reality, virtual reality usage, which was predominantly used for entertainment purpose in gaming or some sort of experiences that was meant for consumers. But more and more, it was understood that it can also be used for industrial usage. Now, spatial computing is a larger form where not only these VR, AR glasses or devices are being used, but also other sensors and other technological, combinations are being used to represent a larger view of a, digitally, I would say, immersive, interactive view of the environment or the surroundings. Now, I would also like to take this time to explain why we are showing cognitive digital twin and spatial computing together here, because we see these two technologies enhancing each other's capabilities significantly. And what it provides in terms of end result is some of the points which are mentioned here. Like you can see, enhanced decision intelligence, real-time interactive simulation, these are some of the things we will explain as we go on into our conversation.
That was, that cleared the air about, these two technologies. We got a hang of what these two are. Jason, would you like to add something around it, since, you're the hardware expert and, you can probably put some light around, from the hardware perspective?
Yes, I know. Basically, I would like to touch upon the enabling technologies that made spatial computing and cognitive digital twins possible. I mean, from the hardware perspective. So, 10 years back, I mean, this idea was already, I think, proposed maybe 20, 25 years back, but it came to a reality with the growth of large-scale, low-cost sensor development and also computing capabilities, including the redefinition of parallel processing by NVIDIA for handling AI workloads. So from the hardware point of view, these two technologies emerged because of developments in various technology sectors. So I think that is a one key point. So it is I mean alignment of the stars, like something like that. You could say it in that way. So that every other technology that is enabling this has developed on its own path and has boosted these two technologies for real world application. So that is what I have to say from the hardware end.
That's interesting. So coming back to you, Sam, yeah, how can these immersive technologies like AR, VR significantly enhance the user interaction? And how can they improve the insights derived from digital twins? Also, are there any other technologies similar to this that can elevate, the implementation of digital twins?
I believe there is a symbiotic opportunity for these two technologies to create a larger, I would say, potential or larger application areas, space across markets. Now, if I mention two factors, one is, user intuitiveness. Uh, I'll tell you about the second one, but I would like to talk about this one first. Now, cognitive digital twin already is using, AI and machine learning to make the digital twin advance, right? But what spatial computing is giving is an additional control or enhancing that experience to be able to, use the digital twin for more, I would say, efficient way. Imagine a situation in a building. If you have a digital twin of a particular infrastructure or a building, you have a complete digital replica of the building in front of you, and you can look at how the building is being managed, whether there is any issue in any particular floors, or if there are any need that you need to urgently need to look into, like any kind of maintenance or any emergency situation. So those things are already there in digital twin, right? But what spatial computing is giving you a more, I would say, immersive control over these things. The moment you get into a particular, if you find a particular issue and you focus on that, spatial computing can enhance your experience in terms of giving the required or necessary options at the time to deal with. There could be, emergency like situation, but you do not need to control all the aspects of the smart building or a smart infrastructure through digital twin, but only the few ones which are, relevant for that particular moment. That is why special computing is able to give you that kind of control, where you're using, let's say, a VR glass or a VR, headset. You will be able to see the exact situation and have everything at your fingertip. You can control it not with, traditional way, but simply with a wave of your hand is will be good enough to control those things. So it is enhancing that, right? In similar manner, in special computing, where you are putting the headset on for a particular environment, imagine someone who's working in a very, I would say, high risk area or intensive work where there is a life threatening situation. They will be able to have a complete 3D mapped, of the space they're working, and also anything that is out of reach, if it's remotely accessible, the users will be able to access those spaces also using, special computing and combination of digital twin. Obviously there are other technologies that are involved which can make the experience even, better, like robotics and all that. But since, we want to focus on this topic, so I think, in simple words, I think it's a symbiotic relationship between the two which can enhance each other's capability significantly. That was one factor that I wanted to talk about. The other factor was that, the uh, training part. It's like simulation is something that is supposed to give you an idea about something without actually happening. I mean, if you were thinking about, training, uh, say, an employee who is new in an environment, controlling, machineries that he might not have controlled earlier. So that training, rather than giving it hands-on, can be given using digital twin and special computing, and it is more efficient. You can also use the same program to train thousands of people across the world, right? The machineries and everything. If the machinery is not there, you will be still be able to teach those people how to operate on those things virtually and remotely. So I think these are two things. Like one is, like I mentioned, user intuitiveness through the use of these two, and another is the simulative training. These two are two of the most important factors, which is making this highly potential.
That's correct. And Jason, anything from your side, any technology you think will elevate, the applications, or probably, these two technologies?
Yes, definitely. To add on to what Sam has said, I think basically AR and VR technologies bring digital twins to life. So what they do is they convert. Till now, we all we have is a kind of a dashboard analytics. So they basically convert that from a 2D space into a 3D space, which is like spatially anchored, an immersive experience. So, from the hardware point of view, again, we could say that there are headsets in the market, like AR headsets, like HoloLens 2, or there's Magic Leap. These kind of headsets are there that project live sensor data. So the sensor data is almost in real time being projected onto the headset to give a near real world experience for the user. So this kind of technologies. Also, we are seeing the growth in 5G advanced and 6G potentially maybe in next 4 to 5 years. So with the adoption of 5G advanced, there's going to be ultra low latency and high bandwidth network communication capabilities. So these kind of emerging technologies also are going to further boost the immersive experience of uh, in spatial computing and cognitive digital twins. And also to talk about the sensor side, there are spatial sensors. For example, there is growth in 5D LiDAR, and there are depth cameras, and they are able to like stream really dense point clouds into the system. And with also growth in solid state and MEM space or event based cameras and wearable haptics. So we basically have a near real world experience within the uh, digital twin environment. So I think that, for example, we have a pilot training. I think I'm not sure if it's really happening in that area. I think they have a kind of a HUD display which for training new pilots. So in the future, that might be almost a real world experience using spatial computing or CDT. So I think those are some of the emerging technologies. The main thing is high network, high speed communication, 5G, 5G advanced, and 6G going forward. And then we have developments in advanced sensors, including 5D LiDAR or depth cameras or image sensors. And then we have the processing capability at the edge. So I think these technologies are definitely going to propel the future applications.
I believe there are a lot of technologies that, will act as a pillar for these two technologies. And I also, immersive experiences are my personal favorite. And I feel that these two technologies are actually taking us, uh, or probably I would say, taking the immersive experience out of only the gaming arena to, actually the industrial applications. So this is pretty interesting. Well, speaking of industries and the actual implications and applications, let's understand from Devat what all industry gaps are being observed by CloudWorks that can be addressed by these two technologies.
Taking it up from what we were discussing around cognitive digital twins and spatial computing being helping it up around and enhancing the experience of users, as we see in the market right now, even companies at current stage are not able to implement digital twin due to a lot of different challenges that they face. There are a lot of high technical barriers. There are legacy systems involved in IoT. As Jason rightly mentioned, it's been into picture since decades. There are a lot of deployment time issues. There is a lot of cost structure also involved, because if you want to create 3D models, if you want to create immersive experiences, you'll have to host them on expensive GPU. Expensive hardware would be required. You would need those probably hardware glasses, etc., for every user that is going to use. So these are some challenges, or I wouldn't say challenges, but roadblocks which makes it difficult to enter into a digital twin or implement a digital twin in real time, and then go ahead and also add on to different technologies like spatial computing and so on. So that's also where we also have a report being done, where we have seen that only 13% of the interested companies are actually able to implement digital twins in real time. And those are the trends that and the gaps that we have seen. And yeah, over back to you, Hina.
Thank you, Devat. Okay, so yeah, we do understand, there are challenges, that are there in the market prevailing, which can be addressed by these two technologies. And so from here, I think we should move to, understanding what kind of applications can actually, reduce these gaps or probably address, some of the gaps that are discussed here. So, Jason, would you like to talk about some of the applications, or trends, that are relevant in this space?
Yes, actually, as we all discussed, there is n number of applications for these two technologies. Basically, they could be used in any industry or sector. And as Sam and David mentioned, like there are some challenges for application, predominantly not on the technology side, mostly on the macroeconomic or on the practical side of things. So, as an industry expert, he would know the practical side of things. From the technology side, I think right now it has potential application in nearly every area, and the application is predominantly used by major companies. So, to have wider reach to smaller companies, probably we need reduction in cost or better technology access. So one particular, I'll touch upon two particular application areas. One is within healthcare, and the second one is for energy and utility sector. So within healthcare, within healthcare again, there is like so many numerous applications in which we can use. For example, the spatial computing and cognitive digital twins can revolutionize patient care and facility management. For example, you can imagine an operating room where surgeons, they can wear an augmented reality headset and they can overlay live or a 3D model of a patient's anatomy. So this can be derived from their own digital twin, personalized digital twin, allowing for it can allow for millimeter level or high precision navigation around critical vessels. It can be a very highly critical surgery which they can perform potentially with using these two technologies. And again, beyond the operating theater, there could be use in hospital planning, using spatial computing to simulate the foot traffic with the patients who are walking into a big hospital, optimizing layouts to reduce patient wait times. That's a major advantage. They could potentially reduce the wait times of patients and minimize infection. This, for example, in COVID, they could, like pandemic like situations, they could potentially organize everything with high efficiency. And for one other thing is equipment monitoring. So this has application in almost every industry and also in healthcare. So equipment monitoring, particularly in the healthcare, is actually an expensive process because, for example, we have this MRI scanners which are pretty expensive and it takes a lot of effort to maintain them. So in this kind of application, I think there are a lot of opportunities for these two technologies to be applied. So I'd like to touch upon one particular use case that I came across. For example, the company's name is Siemens Healthineers, and it's a subsidiary of Siemens. So basically, what they've done is they've employed a cognitive digital twin to maintain their equipment, predominantly their MRI scanners. So what they've done is they employed lots of imaging sensors and TOF, time of flight sensors, and to continuously monitor these MRI machines. And they applied AI models like large machine learning models for to analyze the trends of how these machines are operating in their infrastructure or within their area. So this kind of innovation definitely helped them out in lots of ways. So they have reduced their machine downtime and they're able to monitor their MRI scanners operation, and they significantly reduced their downtime, and that has included cost benefits also. And they're also able to do predictive maintenance. So that's one concept that we're talking about a lot about. So they're able to use the ML models to understand any potential damages or faults in these machines, and they are using these for better efficiency. So this is one interesting case again. So this again is a big company, and they have the potential to do that. So that is one aspect. Maybe going forward with cost reductions, these kind of technologies can be more easily adopted through greater range. So we can also touch about the energy and utilities aspect. A US-based company has Xylem. They have partnered with the city of Modesto, and what they've done is they've created a digital twin of the entire urban water distribution network. So these kind of applications are actually possible. For example, like an urban transit network or for smart infrastructure or anything like that in power generation network, or large scale fleet of windmills or nuclear power plants. We could monitor such things which are actually hazardous. For example, windmills are very hazardous for human maintenance because they're very difficult to scale, and for example, nuclear power plants are obviously difficult. So in these kind of areas, definitely a digital twin would be of immense help. And this company has successfully done that. They've applied it to their urban water distribution network, and they've reduced the leak reduction. So we can see the numbers there from 24% to 17% within the first year, and they have significantly reduced their downtime. I mean, in terms of emergency pipe burp incidents and other accidents, they've prevented significantly. So these two are noteworthy examples of application, and again, these two are literally very large-scale applications of these two technologies. So I can over to Sam to maybe we can cover more on other sectors.
So I believe these two applications are actually very important for civilization. So yeah, these are great cases that you've discussed, Jason. Yeah, Sam, I think you also had some application areas that you wanted to discuss. So please go ahead.
Yeah, I believe, much to what Jason has said, you'll see a pattern how these two technologies are being used. So that is why we wanted to provide you all these industries in one place. And if you see smart cities and infrastructure similar to energy utilities are something like emergency response, or urban planning and simulation is something which can be enhanced as well. If you think about emergency response, anything AI assisted, I would say response, or in a situation where scenario prediction is not possible, right? For different people across who might have enough experience about things. So scenario prediction, and then accordingly all the options to be available in a spatial computing, platform is something where not only the person who's handling the situation has all the things which are relevant available to them, it is also easier for anybody to monitor away from the situation, who's largely probably sitting at a headquarter looking at a similar situation happening across, like pandemic example that Jason took. So those are something that it is possible when you are combining these two, like the digital, cognitive digital twin and spatial computing. It is possible, and it significantly enhances human life, or how the quality of services that are provided, even if it's not an emergency situation. Like if you look at smart cities, how urban planning is done, or if you look at any particular, let's say, city, and a city like Singapore already is doing it. I will speak about it, but to give you an example, if you can go to the next slide. Yeah, you can look at this urban planning and management, where virtual Singapore is something of a platform that has been around for over a decade. But back then it was a more static representation of the city, didn't have as much control as today. Over the past 10 years, they have evolved it. They've used digital twin, but now with cognitive digital twin and spatial computing, they're able to look at the urban space in a more detailed manner and can handle any kind of situation more efficient, because across the city there is a lot of development happening. So they have a real-time update about any particular part of the city where there's construction happening, and there are the traffic needs to be rerouted. All those things can be not only seen, the prediction also is there that if it is not handled, it can get worse. Plus the relevant options are presented to you right in front of you, without having to control any, I would say, multiple devices, multiple controls which might be there in the particular hub, and you can do it with the wave of a hand, or with a few uh, command also, with spatial computing. So that is what is something that is happening, and you can see the outcome. Although not quantitatively it's visible, but efficient urban spaces, and then optimizing infrastructure projects. These are something that cannot be denied, that has significant effect on overall how a city is developed, and the quality of life is also maintained, right? So this is something that I feel is very important. If you can go back, one more thing is retail and consumer. I'm not going to get into a detail, but if you look at how the shopping experiences are changing, we have been seeing a lot of development around retail specific things like smart mirror and all that. But if you want to immerse the consumers, the best way to do is to give a digital representation of things, which is only possible with right now smart solutions like cognitive digital twin, with a combination of obviously spatial computing. There are challenges, like we believe that not everybody will be having a VR headset right now, right? That is a challenge that we need to think of. But as per industry interest, and as per development, there's a lot of development in retail and consumer experience as well. Yeah, I do not have a case study, but there are other case studies that can be looked into. But I would love to hear from Daivat about his point of view about applications and what are the different things that are happening.
Thank you so much, Som. So while we are talking about real-time applications and where industries have actually utilized cognitive digital twins to make some impact, what I have seen is it starts from a level where we can go back to the application slide, Reena, as of now. I'll come back to this slide later. So while we are talking about core applications right now that are happening, definitely there are challenges like not availability of hardware like VR headsets or AR glasses would be an issue right now. But what I've seen is industries have started to understand that this is the next steps towards better efficient production, efficient operations, any sort of line downtime reduction that they want to do, and this is across industries. So we have reached a stage in IoT at such that there are abundant of sensors right now available giving out unstructured data at every second, and we all know that the amount of data that we are generating every day is increasing, and we don't have the right compute and the right uh, model right now to actually integrate all of that data and analytics in real time. And that's where cognitive digital twins are coming into picture, where you are able to have an umbrella software to manage entirety of your asset. It wouldn't matter how much detail would you want an overview of your asset, or if you want to go, you can go as detailed as uh, maybe a nut or even a bolt. If you want to see inside your asset, you'll be able to see in a digital twin, and it's covering your production, it's covering your operations, maintenance, everything under one purview. And if your maintenance guy is not well equipped with the technical understanding that otherwise is required to even go on ground and repair your asset, you would have a real-time 3D view with the spatial computing overlaying between the real and the physical world, which is constantly there guiding him throughout the process. So that actually removes the need of technical expertise otherwise required on ground, where you would see a lot of companies flying down engineers from different parts of the world to actually do a lot of maintenance activities ongoing. There will be downtime induced to even train people. Now you will have better training scenarios, better simulation scenarios, where people are able to use more number of their senses, have an actual immersive environment which is directly going to be replicated of how they are going to work in the industry. So those are some of the examples that I have seen, and this is what for one of the I'll give you a very good case study also. So for one of the biggest European car manufacturers, the problem statement that they came to us with was that they wanted to reduce line downtime. They had that one entire line of cobots, which is sorting packages, auto parts, etc. And even if one of the cobots in the entire line goes down, the entire production is halted. And that's where they wanted our help using digital twin. And surprisingly, what we were able to achieve in a short period of time was that we were able to reduce almost 10% of line downtime. Now, that is without even implementing spatial computing and other core aspects of the deep tech, which we are currently discussing, by implementing just the digital twin. So you can imagine the impact that would come into picture when humans, AI, IoT, and as well as such technologies like spatial computing come into picture, how beneficial it's going to be for various industries across the globe. So that would be my take there. And over to you, Hina.
Yeah, thank you. So yeah, these are some of the very important applications, that we've discussed here. It just not, covers like one bit, like, any other technology would do, like blockchain or quantum would do. This is something that can actually, cover a larger space, smart cities, manufacturing, wholesale, retail, everything. So I believe, these two technologies are going to take the front seat, and AI will eventually, take a back seat in the coming few years, and we will see more and more new emerging applications around it. For that matter, I also came across, an example from NVIDIA. They have an Omniverse platform, which integrates digital twins with real-time spatial computing, and it creates a shared virtual space for design and simulation. So this approach not only accelerates innovation cycle, but also democratizes access to the cutting-edge technologies, and specifically for smaller firms that have previously lacked such capabilities. So, talking about this particular solution, CloudWorks also has a very intriguing solution that Daivat is going to talk about. I really like the solution. Hope, our viewers also like it. So, yeah, please, Daivat, go ahead.
Thanks. So, while we address the industry challenges initially during this webinar, uh, now I would like to address that how we have tackled those challenges currently for companies and how we are addressing them right now. And how we do it is we are right now, we have our own studio and framework. We don't use Unity or any other license to create 3D models. We create it on our own studio and framework using technologies like 3JS, JavaScript, and more. And we are able to ingest data in real time or from all the central categories out there. So you can imagine data from your production operations. You'll have a lot of MES and ERP systems already in place. You'll have PLCs, you'll have sensors, you'll even have AI based data. Every company is now working on their own AI models. They are also working for predictive analytics, utilizing their data in the most efficient way. There'll be a lot of raw video feed, and even unstructured data will be involved along with processed data. And I'm sure you understand the variety and the amounts of data that companies are generating. And we would be able to take all of that up, analyze it in real time, and give it to you in a on top of the 3D modeling that we do, which is directly accessible via web browsers and web apps. And we have created a no code platform where in fact your team would be enabled to drag and drop elements into your universal scene diagram, as you rightly said. And you wouldn't need to rely back on us. Okay, if I want to create a 3D asset, you would have to come back to us again to add a couple of changes in your digital twin environment and all. And all of this in lines with the spatial computing is also compatible with WebXR. So if you want to have an immersive experience of your entire facility, you can simply shoot this up in a Meta Quest 3 or an Apple Vision Pro, and you'll be able to have the same level of access and detail. And what example right now you're seeing on the screen is actually of that auto part sorting and inspection facility for a company in Spain. And yes, so that would be about us. We Our deployment time is also just 6 to 9 weeks, which is also currently an industry challenge, since we have our own studio, our own framework, and we are able to optimize it on such a level that you can basically access your digital twins from your phones. So that is the level of optimization, and mass accessibility is something that we are trying to solve for digital twins. Because right now, as we see, AI has boomed. AI has already become it has already become a commodity. I would it is soon going to be, every phone is going to have an AI. Similarly, digital twin is emerging right now. So is spatial computing, and we are trying to solve the problem of trying to make it mass accessible. That's what we do here.
I find the solution
Back
very
to you.
interesting. Okay. Okay. Do you also want to talk about some of the features that are there, or
Yes, yes,
I
sure. So it's very basic. So I'm sure when we talk about digital twins, everybody would have an idea that it is around 3D models, and that is the lowest hanging fruit a digital twin can give. Like for example, if you have a 3D replica of a building, that is the lowest amount of information that you can get: how the building looks like, how the building is visually, what are the depths, all of the other details you can look at it by seeing. But now when we add real time data to it and real time control over it, the entire game changes. Once you have the historical data, the real time data, you are able to give your customers predictive maintenance. Now imagine if one of your assets is going to fail. Current systems are completely reactive. You will get to know that your asset is failed, you will be alerted in real time, and then you'll act on it. You don't have a system right now which is telling you, okay, your asset is going to fail, or there is a likelihood of your asset failing in the next 2 weeks unless you take X, Y, and Z steps. So that is what predictive maintenance is about, to make sure that your production is going on for the longest amount of time that it can, the downtime is minimal. Any sort of optimization that you can have wherever you are lacking in an industry, it could be for your assets, it could be for your human resources, it could be on the basis of energy consumption. And as Sam also rightly mentioned that initially, that scenario simulation is a huge part. Now you see the kind of training that people are able to get in digital twin versus people who are getting trained on traditional dashboards. There is a huge difference on the amount of experience, and the user learning experience also is there. And we are able to achieve all of this without any expensive hardware, or using any servers or GPU to actually host or run it, which also solves the problem of customers adaptability, where they wouldn't have the amount of cost or the kind of resources to do that. So that's what are the features are like, and I would hand it back over to you, Hina.
Thank you, Devat. So, isn't it an intriguing solution? I was amazed to see this one. So, yeah. Well, I believe that, as Jason earlier mentioned and Daivat now mentioned, the GPUs, the networks, the other creative technology solutions, all of these, are going to form, or I would say are essential, for these two technologies to run. They can't independently, work around, but yes, all these other technologies will elevate the functioning of the cognitive digital twins and spatial computing. So let's ask our experts now, what do they think are the challenges that will show, during the adoption or functioning of these technologies when working together? Sam, would you like to,
Yeah,
uh,
right. So Daivat has already mentioned most of the things which are considered as major. So some of the things which I think will be on a little long-term challenges that we will likely to face if we think from a global adoption point of view. And three of those things I'm going to talk about. Like one is I think interoperability, which are very basic. When we think about companies who are going to or who are planning to adopt, cognitive digital twin and spatial computing as a combination or individually also, the first question that comes in whether it is going to be obviously about cost, but I'm not talking about the cost part. I'm talking about companies who are willing to, take that risk, and but they would like to know whether it will be operating well with the already existing system or ecosystem that they have. So compatibility or interoperability is something that needs to be addressed. I think that is one of the second phase challenges that are likely to be visited once everybody looks beyond the hardware part, or whether the hardware capability or whether the capability of the GPUs and all those things apart. Interoperability of the existing could be already some of those are digitally enhanced, as in what I'm talking about is those are not traditional machineries. They are already having some sort of IoT in space, but or some sort of predictive maintenance are in already in place, whether they are going to be operating well with the new solution. That is something of a challenge for most of the companies, because we know that across the world there are different providers or vendors. Different combination of devices are being used. So how interoperable they are, it is something of a challenge, and needs to be seen and addressed across the world so that it can be adopted well and fast, right? Obviously, when I say fast, I'm talking about within the next 5 years, right? Because nobody wants to stay behind when the adoption is happening. It's a very high, I would say the maturity is very high for these kind of technologies. And if you're adopting something today and a lot of changes are happening, a lot of upgrades or a lot of features being added, you don't want to miss out on those. And if you cannot adopt these because you're not sure about the compatibility or interoperability, then it's I think something that we need to look at or address at as early as possible. Data complexity, I think Davat already spoke about something that his company is looking into. Why data complexity is a major thing? Because a lot of companies do not know how to handle huge amount of data. When a company is completely going for a digital transformation, is likely to be a lot of information being collected, so that that prediction, like the predictive maintenance or like situational prediction, those things to happen. There's a lot of data that is collected day to day, right? So how to handle that data, what data to keep and what data to delete over time, how to archive those data. This is something that every company needs to look into as well. And I think uh, a lot of partners need to step in and help them with that initially. So data complexity, handling those huge amount of data, and what to keep, what to track. Not every stream of data is important for all kind of companies, so those decisions need to be made. So that is why the data complexity is another major, I think, challenges to look at. And I think security exploitation, it goes without saying. I'm not even going to get into details into this, but the moment you go for digital, infrastructure anywhere, like digitization of uh, any operation, there's a lot of new risk avenue opens up, right? Because it is connected through the internet or intranet, but still it can be exploited, right? So the security enhancement part goes without saying, both for data security and operational security, is something that needs to be addressed as well. So I think these three that needs to be addressed.
I completely agree with you, Sam. I think security and interoperability, or I can say integration, is something, which are like the essentials today for any technology. So, if we are building such a complex, technology environment, or something which addresses the infrastructure scenario, I would say these two are highly, highly essential. So, moving from here, I would like to understand Daivat's perspective. Any challenges that CloudWorks is facing or believed to face, as the company and its solution grows?
The current challenges that we usually face depends from region to region and the scale of the company. As of now, what we are seeing in the Asian region is a lot of industries have still not adopted a lot of automation when it comes to sensors, even, or the kind of processes that are implemented in the global level in manufacturing. And what problems we see on the bigger companies is there is a lot of inertia when you see that a team is working with a particular set of softwares or are trained professionals on over 20-30 period of years of time on a particular system. And if we suddenly have to change on the ways that they operate or the kind of software or interaction that they're going to do with their assets, there's a hindrance and inertia that we face usually there. Another set of realistic problems that sometimes that we face is, again, I'm sure is going to be solved in the next set of 5 years, is that these headsets and the AR VR hardware components are not very human long time wear friendly. So if you are wearing a VR headset, you would probably wear it maximum in a real time perspective for like 20-30 minutes before your head starts hurting, or it runs out of battery. It has a 2 hour battery life as a 2 to 3 hour max. So we don't see people using such devices on a regular day-to-day basis, where we see industry applications where you will have manpower wearing such assets on top of their helmets, etc., to actually have a view. And once the form factor and the feasibility of these devices become mass accessible, that's when actually we'll start seeing the true benefit out of spatial computing and those sort of applications as well. And currently we are solving it by giving them compatibility with what current hardware is there. And if they require those sort of solutions, they can use what is existing in the technology right now. And we usually provide a web app, which is currently web browsers are mostly highest accessible using a phone or a tablet or a PC. So that's where we are currently giving the kind of solution that we have, but we are also compatible enough to host it in any other environment. And a couple of things I wanted to mention is digital twins can also be used in form of cyber security. So now imagine if you have a replica of the kind of network and other type of securities measures you have put on your around your asset. The kind of testing scenarios that are there on security fronts can also be simulated in a digital environment, where you have multiple different assets and scenario simulation done to check whether if you can bypass a hacker trying to get into your system using SQL injections or pen testing, and many more other methods which are usually done. So you can have those sort of simulations also done by combining multiple different processes and environments right there. So I was seeing that there was a question around that, so that's why I addressed it. Go ahead, Ina. That would be all from my end.
Sam, would you like to add to the question that is there in the chat window, which is about anything on the cybersecurity front, pen testing?
I'm sorry, can't see it right now. Can we address this towards the end?
Yeah, sure, definitely. Okay. So, Jason, what are your thoughts around the challenges? Are there any that we are facing or we may face due to the hardware part?
Yes, actually, Sam and David, they pretty much covered uh, all of the challenges that we are presently facing. So I just want to touch upon maybe a potential future challenge in terms of technology. So the first one is about scalability. So right now we can see that there's the sensor data is enough and more than enough for a good model generation or a good digital twin generation. So in case we're going to apply a cognitive digital twin with high accuracy, I mean, as David mentioned, up to the bolt and nut. So for example, for a large urban transport system, like something like a metro rail or some other power plant system. So we're going to need a lot more of sensors, and synthetic data is not going to maybe cut it in such situations. We might need real data. So in such cases, the number of sensors is going to be exponentially large, even tens of thousands, or even at least in that range. So operating such a large number of sensors is going to be a difficult task. So this is predominantly in the technology aspect I'm saying. So the one option is that one issue is such sensors are not going to be durable. So they're going to be, for example, if it's applied in a remote or outdoor environment, for example, within manufacturing or within an indoor environment, it's going to be fine. But if it's going to be applied in an outdoor environment, or for example, in a mine, or in a oil and energy sector, or in a maritime or shipping industry, something, or even in agriculture, I don't know what application is going to be there, but potentially in the future, if it's going to be applied even in defense or surveillance areas. So there's going to be sensors in the field that are operating in hazardous environments. They're going to probably need a good, a durable system. So that and should be at a lower cost. So this is a major challenge that companies are facing right now, and some companies are thinking in the long term. So to potentially solve this, for example, one area is the telecom sector. For example, Hina and Sam, we previously worked on the application of AI in telecom with 6G. So there we could see that the ambient IoT or energy harvesting technology, something like that. Well, their companies are working on such things so that they could have a sensor nodes, which are essentially like working in the long term, and they could use AI to basically keep on operating if there's a failure in a particular node or a few sensors is going to fail. So they need to keep operating on their own. So for these two technologies to work properly with high accuracy in large scale areas, so I think scalability is right now an issue, and unless this real world data generation issue is solved, and also the power consumption area. Power consumption of sensors is again an issue. They're going to be definitely battery operators, so they need to be sustainable for a long time. And again talking about sustainability, they should not affect the environment, and they should not be of a negative impact to that area. And they should be able to sustain for a long time. And for example, if you're going to move edge compute in a powerful edge compute, for example, if there's going to be a high density chips which are being developed, and they're going to be able to handle large AI volumes, large data generation at the edge. So they're going to need a large power source. So that is not possible in, for example, in our cities or even in remote areas. So that is one major issue, because as data volumes are going to increase, the power required is going to be exponentially higher, at least significantly higher. And there's also this thermal management, for example, heat generation, cooling systems are needed for edge devices, GPUs require cooling system. So these kind of things, I think, are potential challenges in the future purely from the technology aspect.
So we do have quite some challenges to be addressed before we move forward. So yeah, in fact, what I believe is technology environment is getting stronger. And at the same time, economic landscape is also changing, specifically because of the Trump effect. So our future is good or bad. Only time will tell. But I'm sure we'll sail through these high tides as well. So yeah. Okay, so let's ask the panel now, what are the emerging trends or innovations that are expected to basically redefine the capabilities of these two technologies in the next 5 years? How are we going to see our future with these two? So, Jason, would you like to, put some light around that?
Yeah, sure. Yeah, I'm just going to talk about the challenges which I was mentioning, right? The edge computing capability, power consumption, and scalability. So I think definitely there is going to be improvements in those areas. For example, edge computer is definitely going to be better. For example, I think right now we have around there's a hybrid version of cloud and edge for digital twins. So it is, I think, around 50%. Some companies are using predominantly web-based or cloud-based, while some companies are trying at least up to 15% of edge-based. So in order to have a real immersive field, because I'm talking about the full potential of these two technologies in the future, where there will be a real immersive experience. In that case, the cloud computing alone is not going to make it happen. So there needs to be a really powerful edge computing aspect. And this should be around, for example, 95% of edge compute to have the good speed and network, and remaining 5 or maximum 10% should be cloud-based, so that they could train larger AI models in the future, so that they could have a large-scale data training. So I think edge computing will be the go-to aspect right now. And we can see that companies like NVIDIA, Intel, Google, Apple, GraphCora, they are developing like customized application-specific integrated circuits, ASICs, and FPGAs that use computer fusion and sensor fusion, and these kind of things are happening. And there's also going to be customized AI accelerators, which are potentially going to be used. And there's new technologies coming in microelectronics, such as in-memory computing. And we have neuromorphic computing, which is again nearly like an anthropomorphic, it's similar to a human brain. So these going to be there are going to be improvements in these areas, and these technologies, edge computing improvements would also definitely lower the cost of VR gadgets. Definitely, the lowering cost will be a side outcome of this. And in terms of data generation, there's going to be next generation lidars, or there's R&D taking place in quantum sensors, which is a very new topic, and it's been in discussion for a long time, but we are making progress in that area. So quantum sensors could be a huge problem solver with ultra sensitivity, even up to a microscopic level of accuracy in a digital twin. So we could see that these kind of trends are happening, and hopefully, if the progress that we are maintaining right now, that maybe in the 5 to 10 years, we'll all be meeting again in a different version.
That's true. And talking about the microscopic level, I mean, that is mind blowing, I believe. And for that matter, I think CloudWorks also, right, they will can provide the proximity of up to centimeters and millimeters, right? So
So we
how
provide. So when we talk about level of detail, there are usually four levels, like level 1 to level 4, and the highest level of detail would be accurate to 1 millimeter, or the kind of deflection that you would be see would be in zero point 0.2 or 0.3 millimeter deflection in that. So it's that accurate when we come to it. And I also see a question in the chat that what is the expected timeline for more user friendly wearables that will hit the market. So to that I would say we have just started with the Meta Quests and the Apple Vision Pro, and you can imagine the kind of candy bar phones that we used to have before, and the amount of time it took to evolve into the smartphones that we have right now. So every year we are seeing slimmer phones. Every year we are having newer, smaller chips which are even more powerful. So we cannot definitely put a timeline on when would be a next wearable which would be mass accessible or that ways, but I'm sure there are improvements happening every year. And there is a new lithium ion battery which is even higher density. There are screen pixels which are becoming better and better every year. There are cameras that are improving to almost human eye level. So I see a lot of tech improving, and a combination of these techs, as you mentioned, Hina, that there will be a lot of supporting text which will come into picture when we actually want to implement these two technologies in real time.
And in fact, talking about the wearables, what I believe is, there are being chips developed. There is, a technology that is being developed which can actually be integrated inside the human body and can, actually measure the vitals very, very closely. And this is something that is still under research and development, and some companies are actively working around it. So yeah, this is something we might see in the near future as well. So yeah. So coming back to the futuristic points, Sam, would you like to add something here wherein we see any sort of deviation or changes or updates that are expected in the next 5 years?
Yeah, I think two things like I mentioned here, generative AI and metaverse, but I would like to talk about metaverse. We have seen a little bit of decline in interest of metaverse in the past 1 or 2 years, right? But I think there is a major opportunity which lies with industrial metaverse, because we were, predominantly pitching for metaverse for consumers, like in consumers, like it's more like a social, next level from for social, interactivity. But I think industrial metaverse has a better opportunity, and that is where I think this amalgamation is going to have a significant usage. And when I talk about industrial metaverse, it could be for a particular industry, it could be for cross industry, which are highly dependent on each other. There you would be able to see how you know companies or partners, they're able to interact with each other for particular area, teach each other things, or even do co-development of things without even leaving their own countries or respective markets, right? So I think industrial metaverse is going to have a significant impact on this and can take it to a next level. And generative AI, without when integrated with these two, not only the prediction space, but also how to react to those changes, like any prediction that comes in about possible possible issues or possible scenario, it can be addressed with generative AI, which is going to give you those responses readily available, make those responses readily available to you, so that you can make a decision making more efficiently and more relevant to a particular topic without getting into any kind of hurdle. So I think these two will have a significant impact on both these technologies, even individually, but I think collectively they will have a much larger role to play.
That's
Back to you.
actually true. Yeah. So, David, any other points that you would like to mention here and probably, want to enlighten us?
I feel digital twins and spatial computing is currently at a visionary and an emerging tech area right now, and soon with the rest of the technologies supporting all the innovations that are going on, would help this soon become into a commodity. And once that is achieved, that's when we'll have the true optimization needed, where we are also using humans, AI, robots, IoT, everything in sync to make sure that we are able to achieve uh, whatever we want to via those digital twins. It could be monitoring, it could be training, it could be predictive maintenance, or it could be for emergency scenarios. For example, even if we dial 108 or 911, we should be able to get a real time response which is based using AI, so that it's the fastest. So where is the nearest dispatch center is going to be, like what is the emergency route that can be taken. And these are just some of the examples. It could be implemented in definite scenarios where a lot of human lives are also at stake. So there are underwater pipelines, there are under land gas pipelines, and there are a lot of reactors as well, which Jacinth mentioned, that it's difficult for humans to maintain and operate and be in those conditions. So that's what we expect, that these technologies will overall not only help in optimizing the revenue, but also help save a lot of human lives, and make sure that we are using technology to our fullest to make the things which are difficult more easier.
Yeah, that's true. And in fact, one point that was coming to my mind was, cognitive digital twins and spatial computing together can also drive significant advancements in sustainability. It can actually, optimize resource usage and, by reducing waste. These technologies can help industries achieve their sustainability goals, which are becoming very essential, as we are moving in the future. So, yes, uh, that's our discussion. That's what our discussion was today. And as we are closing today's session, I would just quickly like to reiterate or mention the points that we've discussed, which are like cognitive digital twins leverage spatial data and insights to make some informed decisions and optimize operations. And where spatial computing also provides the foundation for digital twins by enabling and mapping and understanding of the physical spaces. It's clear that these two technologies are not just futuristic concepts, but are actively reshaping industries in today's scenario as well. And CloudWorks is actually a real life example there. And together, these two technologies enable a holistic and intelligent approach to manage, I would say, complex systems and assets. And it is also revolutionizing the industries in a very interactive and an intelligent way. The synergy basically enhances real-time decision making. And I can say predictive maintenance, and in fact, even operational efficiency. So, yeah, these were the points that we covered today. And regarding the question answers, we are almost over time. So we'll try and answer these questions. Please feel free to reach us out independently as well. And we'll be happy to answer all your questions. With this, we conclude our today's session. Thank you for all the participants. Thank you all the participants for joining. And a special thanks to our guest speaker, Daivat. Have a good day. Thank you.